Alright, so this set of notes is about writing the equation of a line of reflection. This is a worksheet that we did in class as a group assignment, but I'm providing you this video so that you have some way to practice it if you didn't quite understand it in class or you just need some more review of what's going on. So we start off here with just some basic information. When a point P is reflected about a line M, point P prime is formed. Now remember, that tells us something, that point P is the pre-image. It's the original point, and that point P prime is the image. It's the point that we get after we do the reflection. Alright, remember from the definition of a reflection, if that point is not on line M, it's not on the line of reflection, then M is the perpendicular bisector of segment P prime. Okay, so if we start with kind of a sketch, let's see what that looks like. We've got a point P being reflected about a line M, and that's going to create point P prime. Now, from what we've talked about in class, remember this segment connecting them then is cut into two congruent parts. We have, first of all, this point right in the intersection. And remember from notes that we said that that was the midpoint of the segment. And the other thing that we talked about was the fact that the line and the segment are perpendicular to one another. So that gives us another bit of information. So altogether, it tells us two things about line M and segment P prime. First of all, that they intersect at the midpoint of the segment. And secondly, that they are perpendicular. So the line M is perpendicular to that segment. Okay? Now with that, if we're writing the equation of a line, that tells us some things. Remember, the equation of a line is y equals mx plus b. And we know m is the slope, b is the y-intercept, the value where it crosses the y-axis, and x and y are the coordinates of any point on the line. So in this case, if I look at the line, remember I have one point right here, that midpoint, that is on the line. So I'm going to use x and y as the midpoint of segment P prime. Now as far as the slope is concerned, if I know the coordinates of point P and I know the coordinates of point P prime, then I can find the slope of that segment. If I know the slope of the segment, then that takes us back to this. The slope of the segment is the opposite reciprocal of line M. Okay, so I'm going to find the slope of the segment, use its opposite reciprocal for the equation, and I'm going to find the midpoint of the segment because that allows us to fill in x and y in our equation. So there's two things, midpoint and slope. Okay, so on this next one I've got point P at 4, 6 and point P prime at negative 8, 12. So I want to find the midpoint of the segment, and remember the midpoint says you average the x's, x1 plus x2 divided by 2, and we average the y's and divide by 2. Okay, so in this case, x1 is 4 plus negative 8 will make this minus 8 divided by 2. And on the y's, 6 plus 12 divided by 2. Okay, so my midpoint becomes negative 4 over 2, 18 over 2, or negative 2, 9. The other thing I said I needed was the slope of P prime. Remember, slope is y2 minus y1 over x2 minus x1. So the slope in this case, m equals 12 minus 6 over negative 8 minus 4. So I get 6 over negative 12, or negative 1/2. Okay, so to write the equation of the line then, the equation of a line is y equals mx plus b. The slope of the line has to be perpendicular to the segment, so it's got to be the opposite reciprocal of this negative 1/2. So opposite changes sign, the negative will become a positive, and we use the reciprocal. 1/2 becomes 2. For x and y, we use the midpoint. So in this case, our x and y values are negative 2 and 9. So we go ahead and fill that in. 9 equals 2 times negative 2. We don't know b, so we'll leave that as is. Multiply the 2 times the negative 2, and then add the 4. So b equals 13. So the equation in this case, y equals 2x plus 13. And that would be the equation of the line that is the line of reflection between P and P prime. Okay, let's do one more. In this case, we're given point P is 0, 9, and P prime is negative 1, negative 15. So we start with the midpoint. That's a point on the line of reflection. x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. Okay, so 0 minus 1 divided by 2, and 9 minus 15. Remember, we're adding a negative. That's where that minus comes from. So we get negative 1/2 and negative 6/2, which we can reduce to negative 1/2, negative 3. Okay, now we need the slope of the segment. M equals y2 minus y1 over x2 minus x1. So negative 15 minus 9 over negative 1 minus 0. Negative 24 over negative 1 equals 24. Now onto our line of reflection. Y equals mx plus b. So the slope of the line, remember, is the opposite reciprocal of the 24 that we got here. Opposite makes it negative, reciprocal 1 over 24. Our xy point is that midpoint. So we use negative 1/2, negative 3. Okay, so we fill them in. Y equals m times x plus b. Multiply. Get a positive 1/48 plus b. We're going to subtract that 1/48 and get b equals, let's see, negative 3 is equal to how many 48ths? Well, 48 times 3 would be 120 plus 24, so 144. We're going to subtract 1 from that and get negative 145 over 48. And those aren't reducible, so we leave it that way. So y equals m, negative 1/24, x minus 145 over 48. And that becomes the equation for the line of reflection. Okay, so on your note sheet you have 4 problems that you can then use for practice. Just for your information, you should not have any fractions for m or b on the first 3. But on the last one you will have. Good luck.